Almost every application needs a logger, and in this tutorial I'll walk you through the logging system I've built. It's not perfect, but I've used it in multiple applications and continue to refine it over time. Throughout the video, I'll point out areas you might want to customize for your own needs. This video focuses on the basic functionality of my logger, and future videos will cover the improvements I've made. If you're interested in using or modifying my logger, the GitHub link is in the description. Let's start with a simple program that prints a message to the console. I personally like the style for message formatting, so my logger will follow the stream usage style. During testing, I found that on my system. A Ryzen 7 5000 series with 64 GB RAM. Formatting a standard log message using std ostring stream takes an average of 0.3 microseconds, if this isn't fast enough for your needs. Or if you're working with less powerful hardware, consider using std format, which was introduced in C++20. I'll set up the logger files with empty init and shutdown functions to wrap any log-related operations. While most applications keep the logger active for their entire runtime, some cases, like performance-critical or production environments, might not. To keep things straightforward, I'll encapsulate the whole main function. The init function needs some arguments. The logger adds extra information to every log message, so the user needs to specify the format. A flag to determine whether log messages should also be printed to the console. The directory where log files should be saved. A name for the main log file. Whether logs should be appended to an existing file or if the file should be overwritten. First, in the init function, I add a check to make sure the logger is not initialized multiple times. For now, I'll just print an error to the console and exit. Next, I need to store the provided arguments. Then create the log file directory if it doesn't already exist. If no errors occurred, I need to open /create the log file in the corresponding mode and store some general purpose information. Whether the log file is overwritten or appended to, I always store some general purpose information to indicate the initialization of the logger. Don't forget to include the necessary headers. For now, the shutdown function is relatively simple. I just need to ensure it's not called before initialization and properly close the log file. The init function call in main now needs a log message format. For now, I'll just show you a basic format, and later, when implementing the formatting function, I'll explain each element in detail. Log messages typically have different severity levels: trace, debug, info, warn, error, and fatal, so I'll create an enum class for the severity. I'll quickly define some shorthands for numerical types of different lengths in a utility module. Since I'll need this module later for non-logger functions as well, it makes sense to place the shorthand definitions there. As mentioned earlier, log messages follow a specific format. I want to allow users to set a new format at runtime, reuse the previous format, or retrieve the currently used format. Next, I need the actual function that logs a message. Every log message should include some metadata, the severity level of the log message, information about the call location, such as the file name, function name, and line number, and then, of course, the actual message to be logged. Both the set format and use previous format functions are very basic. They only swap the format string. While optimizing them to avoid redundant copies as possible, it's not a priority since they are rarely used. Still, I ensure the log file reflects any format changes to keep things clear and consistent. Now let's move on to the main log function. I first define some helper variables. Then I iterate over each character in the format current string to check if it's a format specifier prefix. The format string consists of regular characters and a format specifier prefix. In my case, I chose the $sign as the prefix character, because it's a character that doesn't typically appear naturally in log formats. However, you can choose whatever best suits your application. Keep in mind that the $sign is only treated as a format specifier prefix inside the format string. In actual log messages, it will be treated as a normal character. If the current character is a normal character, I'll just add it to the filled format stream. After detecting a format specifier prefix, I need a switch statement to handle each formatting command. I define these colors for the severity levels using ANSI escape codes, but you can use different ones. If your primary output method isn't the console or doesn't support ANSI escape codes, you can replace them with whatever codes you need. I also added an array to store the names of the severity levels. In the switch statement, I gave meaning to every format specifier. You can choose your own characters or use this approach to introduce entirely new formatting elements. For the basic infos, I defined. B indicates the start of color, E marks the end of the color, C represents the actual log message, L stands for the name of the log severity level, X helps with alignment since info and warn are shorter than the other severity levels, Z adds a line break. For time-related codes, T for the already formatted time, H for minutes, S for seconds, J for milliseconds. For date-related codes, N for the full date, Y for the current year, O for the current month, D for the current day. Here I define a simple macro to make formatting easier. Then, I use this macro in the switch statements that handle numerical values. In the utility module, I've defined a struct called system_time to store date and time information. To retrieve the current time and date, I've implemented a function that works on both Windows and Linux. While I've excluded Mac OS for now, adding support for it would be straightforward, as the implementation would follow a similar pattern to the two systems I've already covered. In the log message function, I first retrieve the current time and date by calling the utility function and storing the result in a temporary variable. This data is then added to the format-filled stream with the necessary formatting applied. For T time and N date, the formatting is done in the switch statement. For source-related information, I defined F for the function name that called the logger, P for a shortened version of the function name, A for the full file path where the logger was called, I for just the file name excluding the path, G for the line number where the logger was called. With all the format specifiers implemented, the final step is to write the log message to the console and/or log file. Since the log file was kept open in the init function, I can write to it directly here. While this works for now, it's not the most efficient or safe approach. Next, in the main function, I'll switch from using standard output to calling the log message function. Because I'm using std_ostring stream, I'll create a new instance of it. Alongside the predefined macros, this will serve as input to the log message function. I'll also set the flag to log the messages to the console for development. Let's compile and run the code to see how the formatted log message looks. Once executed, I'll open the log file in the logs directory to double-check that everything is logged correctly. You'll notice the log message was properly formatted based on the format specified in the init function. Additionally, the log file includes the expected text, which means everything is functioning as it should. For ease of use, I've wrapped the logging into a macro. I opted for macros because I'll define one for each severity level. Additionally, I introduced a log level enabled flag to control which severity levels are logged. This allows me to disable lower severity messages in performance-sensitive or production builds. The preprocessor removes unneeded messages in optimized environments, but I can turn them back on for debugging purposes. Finally, I define the main logging macro. Unlike the previous macros, this one includes the severity level as an argument and routes it to the corresponding specific log macro. Let's test the logger by writing a log message for each severity level and checking the output. The string function of a stream returns a temporary variable. To take ownership of its data, a buffer or move semantics is needed to ensure proper management. I'll implement a buffering system for lower priority messages so they aren't logged immediately. To customize the buffer functionality, I'll define a function to set the severity level threshold and another function to determine the buffer size. After declaring the buffer variables, I ensure that any new threshold doesn't exceed error, so errors and fatals aren't buffered. In the set buffer size function, I adjust the buffer size by first checking its current capacity against the new requirement. If insufficient, I move any buffered messages to the log and/or console and then resize the buffer to accommodate the new size. As previously mentioned, keeping the log file open or repeatedly opening it for every message is highly inefficient. However, with the buffer system, I can now define a function to open the log file only when a significant number of messages have accumulated or when an important message arises. For display purposes, I prefix a D to messages that need to be written directly to the log file. This function is called post formatting, receiving the message string and determining whether the severity meets or goes beyond the threshold. In the init function, I need to reserve memory for the buffered messages. For testing, I call the previous 6 log messages multiple times, incrementing the buffer threshold by 1 level for each block. This demonstrates which messages are buffered at different thresholds. Lines prefixed with D are written immediately, while the rest are buffered beforehand. In the shutdown function, I ensure all remaining messages in the buffer are flushed out. I then set up a basic macro for internal logging, replacing all remaining console outputs in direct log file entries. Additionally, I want to create an exception that logs a message automatically upon triggering. Paired with a macro for easier usage. For validation and assertion, I'll create macros. The assertion macro requires its condition to be true, otherwise it throws the previously implemented exception. The validation macro doesn't throw an exception but let the user specify a command to trigger if the expression is false. This command can be left empty. I'll also add a shorter version ending with _s, which either passes silently or uses the expression as a string in the failure message. For further testing and optimization, I'll remove the D from the console output and ensure log messages are checked for emptiness before processing. In the main function, I'll showcase how the assertion and validation macros work. As mentioned earlier, there's plenty of room for improvement, performance, thread safety, and more. I'll cover these in future videos, or you can check out the link in the description. Even in its basic form, this logging system has served me well. If you enjoyed the video or didn't, please let me know in the comments. Happy coding!